Today we are talking about 7.6, which is factoring out the greatest common factor, okay, or the GCF. So most of you are probably pretty familiar with factoring out the GCF when it comes to numbers. Now we're going to introduce factoring out a GCF when it comes to polynomials. So let's just a quick recap. So let's say we have two numbers like 20 and 30. We want to find the greatest common factor of both. Well, that's going to be 10 because both of them can divide by 10 evenly. Okay. Another example would be, let's find the GCF of 2x and 4. Well, 2 and 4 can both divide by 2, so 2 is the GCF. So now we're going to introduce doing that with a polynomial. So we have 2x squared plus 18. And we want to look at both terms individually and see what is the greatest common factor of both of those. Okay, well, we can divide each of them by 2. And only one of them has a variable with it. So the variable is not going to be part of my GCF. It will be later on. So 2 times what would give us 2x squared? Okay, well, 2 times x squared would give us 2x squared. And then 2 times what would give us plus 18? So that would be 2 times positive 9. Okay. Another way to do that is to simply divide each of them by the GCF, which is 2. The 2's cancel over here to give us the x squared. And then 18 divided by 2 is 9 to give us the 9. So, quick refresher. If we have two numbers that are a little bit larger, like 72 and 48, okay, and maybe we don't necessarily recognize the GCF right off the bat, we can break it down into factor trees and say that 72 is 6 times 12. And that is 6 times 2, and that is 2 times 3, and that is 2 times 3. 48 is 12 times 4, and 12 breaks down to 6 and 2, 3 and 2, 2 and 2. So if I write out the prime factors of 48, okay, then I have 1, 2, 3, 4 2s, so 1, 2, 3, 4 2, so and then 1, 3 times 3. And then if I write the same for 72, I have 1, 2, 3 2s. So 1, 2, 3 2s. And then I have 2 3s. 2 3s. Oh, that's a 2. Okay. And then I want to look for common numbers. So I have a common 2. So I have 1, 2 that's in common. And then I have another common 2, so I have another 2 that's in common. I have another 2 in common. And then I also have a 3 in common. So 2 times 2 times 2 is 8, times 3 is 24. So 24 would be my GCF between these two. And this is your prime factorization. Prime factorization. That's what we would use. Okay, so let's go back to practicing this. So if we have 15y cubed plus 10y squared, okay, I always look at the two pieces individually. So what is the GCF of the numbers? Well, that's kind of easy to identify. Both can divide by 5. The GCF between the variables is a little bit different. So I'm going to expand this so that it's y times y times y. And then 10y times y. And so we're going to be dividing by our GCF. So 5 we know is part of it. And we want to divide by the most number of y's that they have in common. So if I put 2 y's down here, then both of the y's on this side will cancel. And these will cancel as well. They'll reduce to 1. And I don't have anything left on the denominator. So everything on the denominator should cancel. So because I took out 2, that's going to be a y squared. All right, and then I can easily see that 15 divided by 5 is 3, and I still have a y left, so that would be 3y times 5y squared gives me 15y cubed. And then 10 divided by 5 is 2 plus 2. And there's no y's left, so this would be my final factored form with this being my GCF. All right, now let's use that and integrate what we did yesterday. So let's say we have 4g squared equals negative 6g. Okay, well, in order to factor out a GCF, I do need to have them on the same side. So my first step is to get everything on the same side. So let's go ahead and add 6g to both sides. And this equals 0. One thing I do want to point out, the difference between the problem we're doing now and the last two was these two did not have equal signs, so we were just factoring. For this one, since we have an equal side, we are actually solving. So first thing we have to do is get everything on the same side. Then we're going to look to factor. So can we factor out a GCF? So our GCF here is going to be 2, because 2 goes into both 4 and 6. And then the most number of g's that they have in common is 1g, so 2g, since they both have variables. So 2g times 2g will give us 4g squared. 2g times 3 will give us 6g, okay? And then I'm going to use my zero product property to say that this factor must equal 0, and so must this factor, because they multiply to give us 0. So 2g equals 0, and 2g plus 3 equals 0. If I divide both sides by 2, then I get g is 0. And then this one, I'm going to have to subtract 3, and then divide by 2. So negative 3 halves. And that would be my 0 here. So my last step was to solve. All right. That's it for today. Let me know if you have any questions when you come to class.